My name is Alan Jackson, and I'm the Applications Engineer and Account Manager for the WaferSense product line of CyberOptics. We have a line of 5 products. A leveling wafer, which was our first product, uses wireless, wafer-like technology. WaferSense move through the tool like a wafer and do various measurements depending on the product. Then we came out with a vibration wafer, X, Y, and Z, samples 1,000 times a second. Then we came out with a pedestal chamber, showerhead pedestal gapping wafer for very precision, accurate to 1/1000th inch chamber gapping, which is used in most all CVD processes now. And then we have airborne particle sensor. And I have here our new 150 version that we're introducing at the show this year for airborne particle. Counts particles down to 0.15 and 0.5 two-bin schemes. And also we have a precision camera wafer that goes into primarily photo chambers and PVD chambers for precision wafer handoff accurate to 100 microns. The fab is the primary user, and we have a fair number of OEMs. And at the fab level, there's a lot of various departments: etch, PVD, CVD, implant, basically all the departments with the exception of the scanners at this point, because the WaferSense will not fit through the scanners. And at the OEMs, the field service people use it to set up the tools. They use them in the manufacturing process to make sure that the tools are manufactured to standards. Just basically, it practically as many uses in the fab and at the OEMs as there are processes. There was a need to do calibrations and measurements more quickly, to do them under actual vacuum conditions that most of the process tools use, to save data, to have repeatable results, to basically save time. Rather than the tool being opened up and vacuum broken and all the time-consuming effects of breaking vacuum and tearing the tool apart, the WaferSense devices go from the front of the tool at the FOUP, through the front end, through the vacuum lock, transfer chambers, load locks, process chambers, and typically 85% time savings, higher accuracy, improved yield. We've taken our airborne particle sensor technology in the wafer format and reapplied it to the reticle form factor. So we have a reticle particle sensor now that's capable of going in the mask tools, the mask shops, and going through and in real time counts the particles and most importantly troubleshoots and find out where the source of particles are. Traditionally there'd be surface scan wafers, and if you wanted to partition, you needed, if you had 10 chambers, 10 wafers, take surface scans, send them down to the metrology department, wait for the results. Typically it's a process that involves, let's say 10 hours for 10 wafers and 2 individuals. With the WaferSense APS in the reticle and wafer format, send it through in real time, chamber, move actuating parts, and then you're going to find the particle source. Typically in 10% of the time. I was at fab once where a tool had been down 3 days because they couldn't get a handle on it, and within 8 minutes the APS found the bad chamber. So they could immediately start working on correcting the problem and getting the tool back up and high yields again.